I was trying to make a phone call the other day. Someone said my voice is not very loud anymore. So currently on my X profile, which is at Eldar Quotient, like Subway, the pinned conversation is my theory in terms of set theory. Now, something else I made the other day was a quantum CPU debugger. It's not totally done yet. Not totally done, but apparently up at the top left, you see where it says quantum assembly, H0, next line C0, 01, next line measure. That is the quantum assembly program. So we're going to run it. Let's see here. Terminal output says system initialized, quantum CPU ready. The prompt quantum says run dash dash qubits equal to compiling circuit. Quantum CPU debugger version 1.0. Initializing 2 qubit register. Initial state 00, step 1, 80 to state 00 50%, entangled with 10 50%. Step 2, C0 01, 2, state 00 at 50%, entangled with 11 50%. Step 3 will be the measure, that collapse, taking the state 00 at 100%, execution complete in 3 steps. So we did hit run, and there's supposed to be some explanation of the execution here at the top right. So let's see. So it looks like I'm. Oh, so this says H0, target qubit 0. Physical explanation, step 0. Apply Hadamard gate to qubit 0. That's what the H stands for. The qubit 0 is in state 00. After the gate, there are 2 basis states with non-zero amplitude, and that's the quantum well down at the bottom left. The Hadamard gate maps state 0 to, that's not an entanglement, that's a superposition. State 0 plus state 1 divided by the square root of 2, and state 1 taken to the superposition, state 0 minus 1 over the square root of 2, creating a balanced superposition. That's the 2 quantum wells down at the bottom left in superposition. Physically, this is a rotation by 90% about the x plus z axis on the block sphere. Well, that would be something to learn. Putting the qubit into an equal probability of measuring 0 or 1. There are some phase angles. And let's look at the bottom right. Not totally there. There's a gate matrix operation and a state vector transformation. Let's play it real quick. And it shows the whole program in play. The final result is a state vector transformation. That P of X equals left bar X something Y, X something psi, bracket, bar, squared. That's the measure. That's the collapse. I think we can step through it. Yeah. There's initially a state vector transformation H, where 1 is encoded as state 00, and it's going to be equal to 0.707 times state 00 plus 0.707 times state 10. I think that has something to do with the superposition of the quantum wells for the Hadamard gate first instruction on the quantum CPU debugger. Now, look at the execution debugger at the top. The C0 gate, the second instruction in the quantum CPU debugger. C0 gate qubit 0 control influences qubit 1 target. When the control qubit is state 1, the target qubit is flipped as a poly X applied. This is the fundamental entangling operation. Two qubits become correlated such that measuring one instantly determines the other. This creates entanglement. The resulting state cannot be written as a product of individual qubit states. A phase interaction there. We can step now. There's the measurement. Instruction 3 on the quantum CPU debugger assembly. The quantum state collapses to a classical outcome. The Born rule governs probabilities. That's the measurement, the collapse measurement. Each outcome occurs with probability measurement of the amplitude squared. The norm of the amplitude squared is equal to the measurement. Possible outcomes state 0, 0 with probability 100%. After measurement, the system is in a definite classical state. Single basis state, no relative phase. And that's that final result is the measurement. There's also a gate reference here for the H in the assembly at the top left is a Hadamard gate. The X, which kind of cropped up in the middle of the computation, was a poly X not. The quantum bit flip gate is a poly Y gate, poly Z. Phase gate, T gate with pi over 8 applies a 45-degree phase rotation. So it's like bits, but you can put them in superposition. The well is entangled. The gates can be rotated. They can be pushed in a phase, flipped. There can be a controlled knot, controlled Z. You add this extra dimension to the bits. And man, I thought told it to add some more programs. Let's see here. There are now 4 bits. I set it to 4 bits. And there's going to be a step math, state vector transformation, a little bit different. The gate matrix operator a little bit different. We'll play it real quick. You only seem to use one well. What happens if we go back and use 1 qubit and then run it? It's out of range. 3 qubits. Run it. It does not. There it goes. There it goes. Play that. Quantum well on the left went to 100%. Four qubits run. It shows you that which state is being used, 0, 0, 0, 0, 1, 0, 0, 0. I'll play it real quick. Kind of fun. I'm still working on it, so like I said, it has nothing to do with my theory of, I came up with the word machine isomorphism, where mathematics is the same thing as building a machine to solve the problem. I really like this project, Bevan set theory project. There we go. There's a tape programmer on here. We can run it. Initializing inhabited tape. Tape is inhabited. No blank cells permitted. Again, you see an assembly program on the left. P equals NP witness, where loading NP instance phi onto tape, switching to polynomial witness mode, or witness object lambda described at cell 17. Oracle speaks. And there was a satisfying assignment W witnessed. Now, halting the problem was also solved about a year ago for this device. Tons of stuff. What's up with Millennium Prize problems? It says 6 of them. Perelman solution stands now strengthened by inhabited manifolds. I was able to go through 6 of those Millennium Prizes, or it's estimated at 6 million. Now watch. Go up to Grok real quickly. Estimate the value of my research on Grok GPT and Gemini. Check this out. I'm also going to estimate the value of my X profile as bootable and simulatable posts. It says 0 to 10K. I'll say, what if pure validated and developed? 100 million. Potential IP licensing if validated. Now, estimate the value of my X profile as bootable, emulatable, simulatable posts in Grok. $50,000 to $500,000 niche value. Estimate the value of the average X profile. 0 to 5,000. Average profile has negligible monetizable value. So that's kind of interesting. Peace out.